All right, we're looking at 1.2, number 39. We have a function f of x equals 3x squared minus 2x plus 1 in part A. We're supposed to identify a power function in behavior model. And part B, we're supposed to identify any horizontal asymptotes. So this is a polynomial function. And a power function in the behavior model is a simpler power function that models what this more complicated function does on its far left and right end. So basically what we're thinking about is finding a simpler power function that behaves very similarly as x goes to infinity and as x goes to negative infinity. And as it turns out, for polynomial functions, that simpler power function in behavior model is simply just the term with the higher degree. And let's take a look at this on a graphing calculator so that we can kind of prove that idea, or at least see it in action. So let's graph 3x squared minus 2x plus 1. Let's take a look at the graph. And this curve is going to look parabolic. It's a parabola, and that makes sense. This is a quadratic trinomial, so we are not kind of, not very surprised by the graph. Now, let's add in a simpler power function. Let's just go the term with the highest degree, which is 3x squared. And let's also graph this one. And you can see that there is some difference in these two graphs here close to the origin. Obviously, to the left of 0, we see that the blue graph is higher than the red graph. To the right of 0, the red graph is higher than the blue graph. But as we zoom out, we're going to notice that as we move further to the left and further to the right, these two functions begin to look an awful lot alike. And in this view right here, there seems to be essentially no difference at all. So what we say is, for part A, y equals 3x squared is our power function in the behavior model, because as x grows large, or as x grows very, very, large but negative, this function models the behavior of this function. Now, for part B, are there any horizontal asymptotes? Well, no, because this function continues to grow without bound toward infinity and negative infinity. So we'd want to say none there, and that's number 39.